Today, we'll be talking about how to find the prime factorization of a number. And we'll be doing it in Python. So I've opened up repl.it, repl.it, and it's an online editor that you can use to code in various platforms. Whether it be Python, C, Java, you name it. They've got a way for you to use code without needing to download stuff and have an editor. Anyway, I digress. Let's get into it. So as you look at my code here, I will show you how I have set up some prime numbers up here, which I call primes. And then after I have the prime set up, basically these primes are the first less than 100. And they pretty much cover most that most people will need as far as prime numbers to find the prime factorization of. If you do have any questions about that, just feel free to comment and add your input about that. Then I set up a variable here, J, which is going to be kind of like a counter of sorts that let me increment through my array. Okay, and then I have number, which I'm going to change into an integer. As you say, it says equal to int, so I'm going to take the input that I get from the user. Whoever uses this app will enter a number, and then it will be converted into an integer and stored into a variable called number. Okay, and then after that, I set up an array, an empty array at first called facts. Well, these really stand for factors. So these are all the factors that is going to be put into a list of numbers, put in as a list of prime factors. Okay, so then we want to find the prime factors of a number. So we'll say factor is equal to number. So whatever we found as an input from the user, we're going to assign it to this variable called factor. And you'll see why, because we're going to be changing the value of factor. The very first factor that we know to be true is the number itself. That is itself a factor. Every number has a factor of itself and 1. So as long as the factor doesn't go down, is not 1, we're going to loop through this. So that's what this line 8 says, is that I'm going to basically keep on going and reducing down to its prime factors until I can't go anymore. All right, so while factor is not equal to 1, so if a person were to put in the number 1, what do you think would happen? Well, if a person put in the number 1, then it would never even go into this loop. So if it's more than 1, then we're gonna say facts, and we're gonna check to see if it's divisible by one of these prime numbers. Okay, of course this is ordered and it starts from 2, so we want to first see, hey, is it even? If it's even, then we're going to go ahead and continue. We'll reassign factor to be the division or the quotient of the factor and the prime. So say, for instance, it was 12. And we know 12 is even. So when it goes in the first time, it's going to say, well, since 12 is even, we're going to divide by 2. And then that's going to give us 6, right? Okay. Then it's going to reset J. It'll reset J to 0. Okay. Well, J would have been 0 anyway, but I'm just saying that it's 0 now. Right? J is 0, so it's going to stay 0. And you'll see why I reset to 0, because sometimes we might need it to change. So if it doesn't change, that's fine. But if it does change, here it is. J is 0. Okay. So the next thing we want to do is go in and find the next factor. So it's got the 6. So next thing we want to do is go here. Okay, it's 6. If it's 6, then we're going to see first, is it even? Because it's going to go back to 0, right? J is 0. It's going to look at the primes of 0, which is the first element in primes, which is 2. And it's going to say, well, is the modulus equal to 0? That means, is it divisible by 2? And if it's divisible by 2, then we're going to say, okay, well, let's go ahead and divide. So I'm going to move this down here, and we're going to say 6 divided by 2. So it's going to try 6 divided by 2 because its modulus is 0. And then we're good. We're going to reassign factor to be 3. So at this point, I forgot to talk about line 11. At this point, factor is assigned to factor divided by a prime of J, which is the 3 that we got here. But on line 10, we're appending to facts. So we're actually adding our prime factors into our array that we set up on line 4. So we're adding to the end of it our each prime factor that we find, right? So the first one that we find was 2. We found another 2. And now we're at factor being equal to 3, okay? So the next thing we want to do is go back into the loop again. This time factor is 3, okay? And so if factor is 3, hold on, what are we doing here? Factor is 3 now. Is it divisible by 2? Because J is 0 now. We're going to go into the first element of primes, and that's 2. Well, its modulus is not. Its remainder is 1. So the modulus of 3 and 2 is not 0. So it's going to go into this else part of the if statement. Okay, this is going to control the flow, and it's going to say, well, if J is greater than 22, and we'll talk about that in a minute, because we don't want to go through the whole, we don't want to go past the end of the array, because we won't want it to say, hey, we're out of bounds. we don't know this J value. So, so if J is greater than 22, it's going to go into this fact, append number, factor equals 1, break. Okay. Well, it's not going to go in there at all right now. So what we're going to do is we're going to say J equals J plus 1. Because this 14, this if statement on line 14 is not true. J is not greater than 22 because right now it's just equal to 0. Right? So, else we're going to just increment J by 1. So now J is 1. Okay, you see that? J is now equal to 1. All right, J is equal to 1. Then after we see that J is equal to 1, we're going to go back to the loop again and say, well, factor is not equal to 1. Well, factor is equal to 3 right now. Factor is equal to 3. So then, and J is equal to 1. So now that factor is equal to 3, and we look at the second, if J is equal to 1, that means the second index of our primes array. So it's going to look and see, hey, 3 divided by 3, is that 1? Or is that going to have a 0 modulus? Is it 3 divisible by 3? Yes, indeed, it is. So it's going to go in here and say, okay, 3 divided by 3 is 1. We assign factor to be equal to 1. And what do we know about our while loop? Well, it's going to stop right here. It's not going to go any further because now factor is equal to 1. Okay, but it has appended, on line 10, it has appended into facts this third factorization. And I'm about to demonstrate it right now. But this third factorization is what's going to be at the end of our list. Okay, so here we go. We put in a 2, we put in a 2, and we put in a 3. We know that 2 times 2 is 4, and 4 times 3 is 12, which is what we start out with. Those are the prime factors that make up the number 12. So I just ran you through the whole process of what happens when we put in a number into this little piece of code here. All right, so this code segment does find the prime factorization of a number, pretty much any number. I guess after a while, it may miss some if the prime factor is larger than 100. Okay, but we won't worry about that. Most numbers that you will need the prime factorization of are going to have factors that are prime factors that are less than 100. So I think it's safe to use this as a good tool and a guide for most algebra coursework. All right, so let's go ahead and run this code. Okay. All right, let's go ahead and run it. When I hit run, it's going to say enter a number. You see over here on the right-hand side, it says enter a number. Okay, so I'm going to enter the number 56. Well, actually, we should start with 12. Remember the 12 that we went through? When we see 12, there we have it, 2, 2, and 3, just as I described. 2 times 2 is 4, 4 times 3 is 12. So in order to know that for sure this is a prime factorization, they should all be prime numbers, and they need to multiply to the number you start with. All right, let's choose 56 this time. Let's run it again. This time we're going to run it with 56. All right, we see number 56 has 4 prime numbers as factors. 2 times 2 times 2 times 7. Okay, I thank you so much for watching, and we'll see you on the next one.